Hi, let me take this opportunity to personally introduce myself. I'm Aaron Morris, and I'm a computing student at the University of Gloucestershire. For a module 5025, Object-Oriented Programming, I was presented with an assignment brief that instructed me to construct a program that acts as a calculator that can take usual expressions that we know today, infix we would call that expression, and output a result judging on what calculation was put into it. Let me talk you through the way that I implemented this program using the command line interface and the programming language Java. Thanks for watching this video. Okay, so the development environment I've chosen to use is Eclipse. I find Eclipse to be very user-friendly, and the functionality is all there. Very bolt-on with the additional features, so for me, it's the right choice. Firstly, I want to show you the program as it runs. The initialization message contains a testing calculation that is relatively complex, and it's in the expression that we all understand, regular mathematics. We get the result that we wanted there. That is the correct answer, I can tell you. To further understand the way that I've implemented this program, let me show you the UML diagram, the class diagram. As you can see that we have the calculator main here, which there is a class operator, which is the parent class of these chosen classes, which are the separate operators that I use within the program. They're all relative, as they have similar features. They all have a calculation method, except the left parenthesis. And the left parenthesis doesn't contain any calculations or precedents, as the way that they are dealt with is they sit in the stack, and as soon as the right parenthesis is found, which never gets instantiated, which is why there isn't a right parenthesis operator, the program works backwards and computes all of the previous calculations until it finds the left parenthesis within the stack, and it knows that this is the definition of scope of where the calculations with the highest precedence have been calculated. We're using the factory design pattern implementation method with this program. As you can see with the operator factory here, this class, its sole purpose is to instantiate operator objects, and it does this by recognizing the string passed in within the get operator function, which is static, as this function will never change. This is reused multiple times, which is why I've chosen this pattern. It's been removed from all of the main implementation, and it can get called upon from anywhere globally within the program, which makes it very efficient. We have all the different methods here that are used within. The main algorithm that converts the infix expression that we give in to the postfix expression, which is also known as reverse Polish notation, that is how a computer would deal with a calculation, is by using the postfix expression, which some of you may not have heard of. I hadn't before building this program. It was during research that I found this. The shunting yard algorithm is the process that I implemented. It was written by Extra. I'm not sure how to pronounce that. So that is the first main calculations and algorithm that it follows to get the postfix expression there. And then the postfix expression, there's an algorithm that I implemented that can be found. It's widely available and unknown. And I followed this algorithm, implemented it into the program, and that is how I managed to get the calculator to produce the result that we want. Anyway, thank you for listening, and I hope you've learned something or gained something from watching this. Thanks a lot.